Welcome back to my channel of binary trees. Today we will be solving this problem, validate binary search tree. Now what is a binary search tree? Right. A valid binary search tree is defined as the left subtree of a node contains only nodes with keys strictly less than the node's key. The right subtree of a node contains only nodes with keys strictly greater than the node's keys. Both the left and the right subtrees must in turn be binary search trees. Now the problem is to verify if a given binary tree is a binary search tree. Now we will take two values. One is the lower bound, one is the upper bound. I'll explain what this lower bound and upper bound is. Okay. So suppose for this node 24. Okay, suppose for this node, as per the definition of BST, this node should contain a value which is strictly less than 40, right, which is strictly less than 40 because this is the left child. So the upper bound for this, so the higher bound for this should be 40, the value should be strictly less than 40, and the lower bound is this can have any low value. So it is, we are not defining any low value here, so we will for now consider it as null. Okay, now let's check this node, what should be the range of this lower bound and higher bound for this node. So we know this is the right child of 40, right? This is the right child of 40. This should have a value strictly greater than 40. So the lower bound for this is 40 and the higher bound is null. It can have any higher bound, any number. Okay. Now let us consider 14. Let us consider 14. So what should be the lower bound for this? Again, null. The lower bound should be null. What should be the higher bound, upper bound for this? It should be 24 because this is the left child of 24. It cannot have a value greater than 24. So the upper bound is 24. Okay. Now let us consider this value. Let us consider this node. What should be the range of this node? What values can it have? So this is the right child of 24. This is the right child of 24. It should strictly have a value greater than 24. So the lower bound for this is 24. The lower bound for this is 24. What about the upper bound? What about the upper bound? It can have any values? Null? No, it cannot have any values. We'll check this. If we check this node, this parent of 24 has a value of 40, and this node 53 lies in the left subtree of 40. As per definition, all the nodes to the left of a node, okay, left subtree of a node should have a value strictly less than that node's key value, and all the node to the right subtree of a node should have value strictly greater than the node's key value, right? So this cannot be anything. This cannot be any upper value. The upper bound for this is 40 because this is the lies in the left subtree of this 40 of this node. So it should have a value strictly less than 40. So the higher bound for this is 40. Okay. Now let us see how can we come to the conclusion. We have set the upper bound and lower bound for every node. How can we come to the conclusion? So for each node we will check if it satisfies this condition, like the node value should be less than the higher bound and greater than the lower bound. So if each node follows this condition, this is a valid BST. So for each node, we'll check if 14 lies in 24 and null. Null means will not consider this. So if it is less than 24, yes, we will return a true from here. Okay, we'll return a true to its parent from this because till here it's a valid BST. Now we will check the right child. Right child is 58, right? Is this node value lies in this range? Is this condition true? Is this condition true for this? No, this is not true. 58 is greater than 40. It's not true. So we will return false from here. We will return false from here. Okay. So uh, if we are getting false from either the left or the right, so we will do AND operation here. Okay. So we'll compute left child and we'll compute right child or right subtree. Okay, we'll compute left subtree or right subtree, and whatever we are getting we will do and. Okay, and we will return. So if this we are getting a false from anywhere, and will be false, so simply we will not compute anything here, we'll simply return false. Okay, because left subtree, because this and this, true and false, gives us false. Okay, so we'll simply return false here. Now we will come here, we will check this. Is 50 lies in the range of 40? If this condition is satisfied here, yes, this condition is satisfied, so we will return true from here. Again at 40 we will first check the outcome of the left tree and the right tree. If anything is false, we will simply return a false from here. Okay, we'll not compute this. If this is in the correct range or valid range, we'll not compute, we'll simply return false. So ultimately we are returning false from the root. So this is not a valid subtree, a valid BST. This is not a valid BST. This is the solution. You can pause your video and copy it down, note it down. So basically we have used a helper method find, which does the operation for us and finally returns the boolean if it's a binary search tree or not. The base condition we have set as null. If root equals to null, will return 0. At if any point we are finding that the root value is uh, less than the low, or the root value is greater than the high, at that point we are returning false, right? And finally we are setting the lows and highs, and we are iterating through the children. So yeah, thank you so much for watching.